Right, folks. So 2014, we'll do a few things here. So the first one here, complex numbers. We've got Z1 and Z2 up here. And we can see there, you've got your a squared is equal to -1, a key thing. So the first thing, find Z1 minus Z2. So Z1, fill it in, is 5 minus a minus your Z2. So will you have your minus, stick in your brackets. 4 plus 3a. Now, you're going to work out the brackets there. So 5 minus a minus 4 minus 3a. Add together your real parts. 5 minus 4 is 1. And your imaginary parts, minus 4a. So 1 minus 4a. Now verify. Once I see them two straight down lines, that means the modulus. So square root of a squared plus b squared, or the square root of real squared plus your imaginary squared. And you always add them and keep away the minuses, keep away the a's. So we're going to work out the modulus of Z1 minus Z2. And we worked out Z1 minus Z2 up here in part 1. So it's a square root of 1 squared plus minus 4 squared. No y's in it because this is distance, how far it is from the origin. Put that all into your calculator and you get the square root of 17. Now the next bit here, we're going to have to work out Z2 minus Z1. So Z2 is 4 plus 3a minus Z1, which is 5 minus a. When we tidy that up, get rid of the brackets, 4 plus 3a minus 5 plus a. Work out the difference, 4 minus 5 is minus 1 plus 4a. Now we're going to work out the modulus of that. So the square root of a squared plus b squared. And lo and behold, we get the square root of 17 as well. And give a reason. While that will always be true for any complex numbers, it's hard actually to put into words. You know, you still have the same coefficients, the same numbers to be squared. The same numbers are squared, if you like, in the formula. But also, modulus means the same distance from the origin. Or same distance from 0, 0. Next one, find a complex number Z3, such that Z1 is equal to Z2 over Z3. Now, there's a wee bit of work in this. So the first thing here is you must get Z1 on its own. So I'd manipulate it first of all. So at the minute I've got Z1 over 1. Anything that's not a fraction I'm going to put over 1 is equal to Z2 over Z3. Cross multiply, or multiply by the common denominator, which is Z3. Then cross out your Z3s. So I have Z3, Z1 is equal to Z2. Find Z3, so Z3 is equal to Z2 over Z1. So we're always going to be asked the modulus and division. Sub in your numbers. So for Z2, it's 4 plus 3a. And for Z1 there, it's 5 minus a. And when you're doing division, you multiply top and bottom by the conjugate of the bottom. So multiplying top and bottom by 5 plus a. So work out your top. So you've got 4 plus 3a times 5 plus a. Bust your brackets. Times them out. So you got 12 plus 19a, 3 times minus 1. 12 minus 3 is 9 plus 19a. Now work out your bottom. So when we multiply by the conjugate there, we're going to end up with just a number. The i's will disappear. So multiply it out the same way. You see your a squared, the alarm bells are ringing. You can see your a's are going. A squared is minus 1, and you end up with 25 plus 1, which is 26. Now just put the top over the bottom. So 9 plus 19a over 26. Oh, jeez, I can't even read my own writing. That's a 5 there. 4 5s are 20. As you see there, the bracket was 5 plus 8 in the second one. Bollocks. 20 minus 3. 17 plus 19a over 26. 17 plus 19a over 26. Next one, bit of algebra. So, see the brackets, multiply them out. So 2 times 4 is 8, minus 6x, plus 12, is equal to 7x, minus 10x, plus 35. Tidy that up maybe each side. So 8 plus 12 is 20, minus 6x is equal to minus 3x plus 35. Numbers one side, letters the other. I'm going to try and keep my x positive. So what have I got? 20 minus 35 is equal to minus 3x plus 6x minus 15 is equal to 3x, x equal to minus 15 over 3, which is minus 5. Then it says verify your answer. To verify your answer, you're just going to sub it in. Now, you could sub it in ideally to that top line. It's just too many brackets going on for me there. I'm going to sub it into this line here. So 8 minus 6 times minus 5 plus 12 is equal to 7 times minus 5 minus 10 times minus 5 plus 35. And we should get one side equal to the other. And we get 50 is equal to 50. So we know we're right. Now, we've got a simultaneous equation, one linear, one quadratic. Work with a simple one first. The top one. Get one of the letters on its own. Doesn't matter which one. So x equal to 7 minus y, say. Just brought across that y. Then we're going to sub it into the second bit. So instead of saying x squared, I'm going to say 7 minus y squared. Plus y squared is equal to 25. What does something squared mean? By itself. So write out that bracket twice. And then bust your brackets. Multiply them out. And then tidy it up. Do your minus b. So my a, b, c, a is 2. B's minus 14, C's 24. Better write this right so I can see it. And then fill it in. Minus b minus, plus or minus the square root of b squared. Make sure you have your brackets around your b. Always write out your formula as well. I just can't see. Or I don't have enough room, sorry. I can see. All over 2a. And then you fill that in. So you're going to get your y's to be 3 and y to be 4. Now you've got to work out your x. So you fill it in up here. X is equal to 7 minus y. So x is equal to 7 minus 3. X is equal to 4. So that point there is 4, 3. And the other one, x equal to 7 minus y. 7 minus 4. X is equal to 3. So x is equal to 3. Your y is equal to 4. Number 4. You've got to solve the equation. So again, use your minus b, your a, b, c. So your a is 1, b is minus 1, c is minus 6. Fill it in now to your formula. I'll write it out this time, I have a bit of room. And when you throw that into your calculator, you get x equal to 3 and x equal to minus 2. So remember, that's a U-shaped function with our roots equal to 3 minus 2. Now, the graphs of 4 quadratic functions are shown below. Which of the graphs is that one that we just worked out? Remember, another way of saying f of x is y. So where is y equal to that there? Now we know it's a U shape, so it's either going to be A or D. The other thing here, we've got our answers. It cuts it at 3 and minus 2. This one cuts it at 2 and minus 3. So it's not that. And if we look at D there, it cuts it at 3, minus 2, we're good. So graph D. Don't have to give a reason, but the roots, that's what you call it, are 3 and minus 2. Also, cuts the y-axis there, minus 6. Cuts the y-axis when x is equal to 0, which works out to be your minus 6. The graphs of these functions are shown in the diagram. On the same diagram, sketch the graph of the functions g of x plus 2. Okay, so g of x is x squared minus 2x. I wish I could get my calculator up on the screen here. So the first one, we're going to be using our calculator in this, so mode and 3. When it asks you to type in f of x, doesn't matter if it's f of x or g of x, you're going to sub in, instead of g of x, x squared minus 2x. And then it's got a plus 2 at the end. Now, I would go start at minus 3. Now, still, not all these values might fit. You end at 6. And you got steps of 1. Now, get my calculator here and do it. So x, I'm going from minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. We'll see how we get on getting these values. And so mode 3, I'm typing in there alpha right bracket squared minus 2 alpha right bracket plus 2. Skipping that g of x1, I'm doing one at a time. Start at minus 3, end at 6, steps of 1. I'm getting minus 317, minus 210, minus 1, 5, 0 and 2, 1, 1, 2, 2, like a bingo caller here, 3, 5, 4, 10, 5, 17, it's outside it. So I'm going to graph this one now. I'll do it in red, say there. So minus 317, if you want, just goes up there. Minus 210, minus 1, 5, 0, 2, 1, 1, 2, 2, 3, 5, and 4, 10. Now you did see in your thing 5 and 17 anyway. May as well use it. Join that up. Nice smooth curve. It's easier on a page, let me tell you, than this other thing. So that's my h of x. Now I'm going to do k of x. And again, the calculator is going to take care of it. So all we've got to do is, this says sub in instead of x. I'm going to fill in x plus 2. So in my k of x, I'm going to be filling in, instead of x squared, I'm filling in x plus 2 squared minus 2 times x plus 2. Same start, same end, same steps. So AC that. Type it in as x plus 2 squared minus 2 times x plus 2. And what you get out, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. Minus 3, 3, minus 2, 0, minus 1, and then we're going back up again. 0, 0, 1, 3, 8, 15, 24. So we're outside that range. So minus 3, 3, minus 2, 0, minus 1, 0, 0, 1, 3, 2, 8, 3, 15, and then we're out of it. Smooth curve once again, and label it there, k of x. So just use your calculator to work through them. Next one, we're given a function here, x cubed plus 3x squared. So it's a cubic. And when we have a cubic, it's either going to be an s, and it's s, remember Shannon is negative, or Shania, or the other one there, it's just the opposite of that, that's going to be a plus x cubed. So this here is going to be this general shape here, because it's a plus x cubed. Find the point where it cuts the y-axis. Now you need to know something. Cuts the y-axis when x is equal to 0. And another thing, everywhere you see f of x, replace it with y. Y is equal to 0 cubed plus 3 times 0 squared minus 9 times 0 plus 5. So y is equal to 5. Write that point. Remember, a point's made up of an x and a y. Would be 0, 5. Next thing there. Verify that the graph cuts the x-axis at x is equal to minus 5. So different ways you can do it. Thing I'd be thinking, cuts the x-axis once again when y is equal to 0. Need to know that. So I'm going to fill in 0 for my y, which is the same as my f of x. And I'm going to horse in minus 5 for my x. And I should get 0 to be equal to 0 there. And you will. Find the coordinates of the local maximum and the local minimum. Now once you see local maximum and local minimum, alarm bells are ringing. When you see that, dy dx is equal to 0. Maximum or minimum. Now, technically it's f dash x in this one. Makes no odds. You're going to diff it and let it equal to 0. So you diff that, multiply down by the power, reduce it by 1. Do your minus b. Throw it into your formula. And write out your ABCs. And when you do that, you'll get two answers for your x. You get x to be minus 3 and x equal to 1. Technically it says a coordinate. Coordinates made up of an x and a y. To work out your y then, you sub in each value back and up here. So, I'm not going to have much room here. Y is equal to minus 3 cubed. And when you do that, you get an answer of 32. And when you do it for the other one, an answer of 0. So your turning points are minus 3, 32, and 1, 0. And then it says hence. Hence means use all that bits of knowledge, sketch the function. So it told us in A part 1, cuts the y-axis at 0, 5, which is there, it's 5, 10, 15. It cuts the x-axis at minus 5, 0. It has a turning point at minus 3, 32. Say roughly there, and 1, 0. And we said it has a general, this shape, not the S shape, the opposite. So it's going to go up, down, and then up. So we're using our previous answer each time. I'll do sequences, do money, could do that. And that there as well. I'll start with this one. It's question 9. See how time goes in between classes here. So, small rocket is fired into the air. Flight lasts 10 seconds. The height, which is h, in meters, given after time in seconds. Complete the table. Now we're going into our mode 3 in our calculator again. And instead of saying 10t, I'm going to say it's 10x minus x squared. Start at 0, end at 10. Beauty of this, we'll know if we're right from these values here. So when we do that, We're getting answers of 0, 0, 1, 9, 2, 16, 3, 21, 4, 24, 9, 9, and 10, 0. I'm going to draw this. Now we know it's going to be an N shape because it's a negative, like an x squared. So 0, 0, 1, 9, 2, 16, 3, 21, 4, 24, 5, 25. I'm downhill now. 6, 24. 7, 21. 8, 16. 9, 9. 10, 0. Join that up. Nice smooth curve. There you go. So that's my function. H is equal to 10 t minus t squared. It says use your graph to write down the height of the rocket after 2.5 seconds. Now, you could, it said my function there was at the start, h is equal to 10 t minus t squared. If you're cute, you could sub in 2.5 for my t. But here, technically, after 2.5 seconds, you're supposed to, when it says use your graph, go up where it hits the graph from the 2.5 and go across. And then you read off your answer. I'm in at about 18.5. If you sub that in into the calculator here, 10 times 2.5 minus 2.5 squared, I'm getting 18.75, so not bad. The time when the rocket will again be at this height. So what you're doing here is you're going across from that height to where it hits the graph and go down. Now, slightly less than 7.5, I'd say, because I moved it in a wee bit, so I'll say 7.4 seconds, give or take. I'll give a range. Coordinates of the highest point's up here, you actually see it in the table, to be 5, 25. Find the slope of the line here. So when we're given 2 points, label them x1, y1, x2, y2. Nice slope formula, y2 minus y1 over x2 minus x1. And we're going to sub it in. So 21 minus 24, 7 minus 6, giving you a slope of minus 3, which means it's going downhill. Would you expect the points 7, 21, 8, 16 to be steeper than them points? I would just find the slope and then see. So find the slope between them. I'm not going to complicate it. So x1, y1, x2, y2, y2 minus y1, x2 minus x1. You get minus 5. Therefore, it's steeper. The minus just means it's going downhill. The bigger the number, the bigger the slope. So now it says find dh dt. So remember h was 10t minus t squared. dh dt, it's like dy dx, multiply down by the power, reduce it by 1. So 10 minus 2t. Hence, use that answer. Find the maximum height. Once I see maximum, I'm thinking dy dx equal to 0. So my diff there is 10 minus 2t. That is equal to 0. 10 is equal to 2t. T is equal to 5. Now that's the time in which the maximum height occurred. To work out the maximum height, we've seen it in the table to be 25. We're just going to sub it in. So it's a way of verifying it or getting the answer without drawing the graph. Throw it in your calculator and you get your 25, which we said earlier on. Hence find the speed. So speed, once you dy dx, you get maximum speed, slope, rate of change. The speed of the rocket after 3 seconds, you're subbing in 3 for me t, which gives you 4. 4 meters per second if you want to be swanky. And then find the coordinates at which the slope of the tangent, how we say slope of our tangent is dy dx, is 2, equals 2. So where is 10 minus 2t equal to 2? Solve it. T is equal to 4 seconds. Coordinates made up of 2 points, x and a y. Again, you could look at your table and what it was at 4, or you could sub it in. 40 minus 16, 24. So that point is 424. Now that'll do us. It's bloody long enough.